Okay, I think uh, last time we have talked about uh, weight volume relationship, and we have seen a lot of relationship between weight and volume. So before we continue in our program of soil mechanics, I think it better we do at least one example before continuing this program. Okay, so I am proposing this exercise, which is direct application of the formula we have talked about in the previous video, which is the first section of this chapter. So before we do this example, I would like to go back a little bit and talk about what we have seen last time. It will be like a reminder. So I think okay, chapter 3, weight volume relationship, we did introduction and we talk about how we can separate the three phases of soil, because there are three phases of soil in the soil: a gas, liquid, and solid. So we we talked about this definition. I am calling them definition because these are the basic, really the basic information of soil we need. Okay, so void ratio, you need to know the formula of void ratio: porosity, degree of saturation, water content or moisture content, unit weight, dry unit weight, and also, as I told you last time, instead of using weight, we can sometimes use uh, the mass of the soil. Okay, so the water content can be obtained from unit weight, from weight, no, weight of water divided by weight of soil. I mean, uh, grain soil, solid phase of the soil. And we can use also mass. So mass of water divided by mass of soil, really the dry soil. Okay. And density also, we can use density. Instead of unit weight, we can use density. So after that, we have talked about many relationships, how we can, many ways to obtain this more relationship between volume and weight, like this, by taking the volume of solid equal to 1, we can establish all these equation. We have talked about this before. And when the soil is saturated, we can estimate these relations. And these relation, this one and the previous one, are both about how to use void ratio to establish other relationship, to obtain other, to establish some formula. Okay, so after that, we have talked about porosity, how to, if your keyword is porosity in your exercise or in any practical case, then we can use this approach. By taking the total volume of the soil equal to 1, we can establish all these formula. And as you can see, this formula, the keyword or the key parameter is the porosity N. Everywhere you see is N, which is porosity. This is the case where the soil is not saturated, and this one is when the soil is saturated. So after that, we have talked about this relationship. I told you that maybe you just have to, maybe sometime during exams, you are allowed sometime to use this formula. like open book example. Okay, I think we ended up with this table with void ratio and dry density of some natural soil. Okay, so today in this video I would like to do one example and show you how we can apply directly those formula in exercise or in practical case. Okay, yeah, so here is the exercise we have. The exercise is saying in natural state the soil has a volume of 9.34 cubic, sorry, just let me use the pointer. So 9.34 10 power minus 3 cubic meter, and the weight is given by this is this value. So here we have the specific gravity of the soil, 2.67. So we are asked to calculate the moisture content, the moist unit weight, dry unit weight, void ratio, porosity, and degree of saturation. Okay, so we are gonna do step by step this and explain how we can get all these parameters. Okay, first, water content, the moisture content. So if you remember the formula, I told even now as a reminder that we can obtain this water content by using weight or masses. So here we can use weight of water divided by weight of solid phase, solid soil, mean dry soil. Okay, so the weight of water here can be obtained by, because we have here the weight of the water, the weight of soil, mean wet soil. Okay, this weight, this volume, sorry, this volume and this weight are both for the wet soil. It means this volume is the volume of soil plus volume of the water that is in the soil plus volume of void. Maybe the water is the soil is not 100% saturated. Okay, and this weight is the weight of the solid part, the solid grain, and the weight of the water, because this is the wet weight. Okay, so after drying the soil, we obtain this weight. Sorry, I forgot to put here kilonewton. So this weight is the weight of the solid, the soil, the dry soil. After, if you dry soil, what is happening? What is happening is the water will evaporate. Okay, it means that in this weight, the water is gone. So for us to obtain the weight of the water, we'll just take the total weight when the soil was wet and minus the weight of the soil after drying it. Yeah, because in this weight, both water and solid soil grain are included. But in this water, in this weight is only for the particles, the soil particle only. That's why we did here this weight minus this weight to obtain the weight of the water. And of course, the weight of the soil particle is this one, as I explained. So we can obtain then this 15.6% as water content. Okay, so that was the first question. The second question is about the most unit weight, or we can call it also the wet unit weight. How can we obtain this unit weight? We have this formula. Unit weight is weight divided by volume. So be careful here. We are asked to find the wet unit weight, the most unit weight. So we have to consider the wet weight and the wet volume. It said here that the most soil has the volume of this volume and this weight. So it means we have both the volume of the most soil and the weight of the most soil. So in this case, it's very simple. You don't need to think too much. Just take the weight of the wet soil, divide by the volume of the wet soil. That's all. And you can get the unit weight of the wet soil, which will be 19.01 kilonewton per cubic meter. Okay, so that is the second question. The third question is about the dry unit weight. So if we have the wet unit weight, we can obtain the dry unit weight very easily by using the relationship between these two. Okay, so we know that the original formula for the dry unit weight is weight of soil particle divided by the total volume. Okay, that is like a definition of the dry unit weight. But we have this relation between the unit weight, mean the wet unit weight, if you want, and the water content in dry unit. So it's saying that dry unit weight is equal to the wet one, what unit weight, the wet unit weight, or total unit weight, if you want, divided by this 1 plus water content. Okay, so here, I think we can use immediately this one. We have the weight of the soil particle, which is here, this one, because after drying, normally this weight is the weight of the soil particle and the weight of the air in the soil sample. But actually, if you remember, we have talked about this before. Weight of air is neglected always. We don't consider the weight of soil, of the air. So this means that this weight is just the weight of the weight of the soil particle. So weight of soil particle is here given, and the total volume also is here given. So we can calculate this very easily, okay, by doing using this equation. And if you want, if you have time, please try by using this formula. You have this gamma is 19.01. But in that case, when you want to use this one, the water content, you cannot use 15.6, please. Some people are always confused about this. If you want to use this formula, this one should be 0.150 56. It means 15.6 divided by 100. Okay, you cannot use the 15.6 here. If you want to use this formula, it will be 19.01 divided by 1 plus 0.156, and you will see that you will obtain same value of dry unit weight. Okay, this is question number 3, 6, number 3, so C. And D is about the void ratio. So definition of void ratio is volume of void divided by volume of soil particle, volume of solid. Okay, so I think we can obtain the volume of the soil particles by using the specific gravity of soil, because we have here the specific gravity of the soil particles, and we have the weight of the soil particles here. So we know that specific gravity is equal to unit weight of soil particles divided by unit weight of water, which is, again, because unit weight of soil particle is weight of soil particle divided by volume of soil particle. So by using this combination, by using the fact that specific gravity is equal to weight of soil particle divided by volume of soil particle, which multiply by the unit weight of water, we can obtain the volume of soil particles, which will be weight of soil particle, we have it here, divided by this, the specific gravity 2.67, and with this one, the unit weight of water is always constant, no matter where you go, where you are in any, everywhere you go, this one is constant. It's 9.81. Okay, so by doing that, we can obtain the volume of solid soil particles. So because our formula for void ratio is asking us two volumes, volume of void and volume of soil particles. So we have this one. So now let's try to get the volume of void. So for the volume of void, we can do the total volume minus the volume of the soil particle, because in this total volume here, this total volume include the volume of soil particle, volume of water, and the volume of air. And the volume of air plus the volume of water, these two make the volume of void. Okay, so if we do the total volume, means soil particle, water, air, the total V minus volume of soil particle, we will get the volume of void, means volume of water and volume of air. So this volume of void we need. So the total volume, this V, minus the volume of soil particle, which we obtained just now. So total volume, this one, minus volume of soil particle, this one, we can obtain very easily the volume of void. And now we have both things we need to estimate the void ratio, which are volume of void and volume of soil particle. And by making a numerical application of this, we can obtain a void ratio of 0.59. Yeah. So Next is about porosity. If you have the volume of void and total volume, which is definition of porosity. Porosity is volume of void divided by total volume. This V is total volume. Okay, so just we have the volume of void. It's just here. We just calculated it, and the total volume is given. So just we apply this, and we can get easily the porosity. And of course, you can use the relationship between porosity and void ratio also to obtain the porosity here. Okay, yeah. Degree of saturation, volume of water divided by volume of void. What do we have here? We have volume of void. That is here. Okay. Don't forget the cubic meter here. Okay. So the volume of water now, we need to calculate the volume of water in this width, because the volume of void includes volume of water and volume of air. Okay, so we need the volume of water only. So means in this volume of void, we have volume of water and volume of air, but we need volume of water. Okay, so we know about this relationship, that the volume of water, because the unit weight of water is weight of water divided by volume of water. Okay, so by using that, we can say that the volume of water is weight of water divided by unit weight of water. The unit weight of water is constant, as I told you here. It doesn't change. No matter where you are, where you go, it's same, 9.81. Okay, but the weight of water now, how can we obtain that? To obtain the weight of water, we can take the total weight. Actually, we did the weight of water before. If you remember, question number 1 was asking us about the water content. And for calculation of water content, we needed the weight of water. Okay, so just take the total weight and minus the weight of solid particle, and you will obtain the volume of water, the weight of water, as I explained. Because in this weight include the weight of three things: soil particle, water, and air. But the volume of air can be neglected, so it only two: soil particle, solid particle, and water. So if you take this total weight minus the weight of soil particle, you get the weight of water easily. And the weight of water divided by unit weight of water, you get the volume of water. Okay, then you can easily apply this formula, okay, to obtain your degree of saturation. Okay, I think that's all for this first part of the chapter. So we will start the next part of this chapter in the next video. Okay, thank you very much, and see you soon.